Hello everyone, this is Dr. Speights with Math Videos on PowerPoint. In this lesson, we will discuss scatter diagrams, also known as scatterplots. Now, a scatter diagram, often called a scatterplot, is simply a graph of ordered pairs that shows the relationship between two variables. Now, sometimes they also call ordered pairs pair data. So suppose you were given data in a table and you were asked to plot this data. And you plot this data. After you plot the data, you look at it and you want to analyze the data to determine if there's any trend or correlation of the data. Now, this relation can be a positive, a negative, or there may not even be any relationship between that data. So if you notice that your dots are clustered together, moving from left to right in an upward motion, we would say that this is a positive correlation or positive relationship. So notice as you go along the x-axis, as x increases, what's happening to your up and down, your y? Notice it's going up. So as x increases, y also increases in a positive relationship or positive correlation. And so for a negative correlation, if you notice that your data are clustered together and moving in a direction from left to right in a downward motion, that is called a negative correlation. And so with this negative relationship, as x increases, what's happening to my dots, my up and down dots? Well, they're going down. So your y decreases. So again, as x increases, y, my data's going down here, y decreases. Okay, so negative relationship, as x increases, y decreases. And then if you notice your data, you can't determine whether if there was a positive correlation or whether there was a negative correlation because they're just kind of scattered or all over the place. Then we would say that that data has no correlation. In other words, there's no relationship between the data sets. In this example, I want you to determine whether the graph shows a positive correlation, a negative correlation, or no correlation. Now, if there's a positive or a negative correlation, I want you to describe its meaning in this situation. In other words, describe the relationship. So, what type of correlation do you think this graph has? Yes, notice and it's moving from left to right in a downward motion. So this data shows a negative relationship, and the data that's being studied here is the age of a car and the value of the car. So the relationship here, you would describe it first on your x-axis. You would say as the age of the car increases, the value of the car, notice what's happening, decreases. Okay, so to write that, you would write it like so. Again, as the age of the car increases, the value of the car decreases. And we know that is so true. Cars, they simply lose their value over the years. You can practically drive them off the lot, and if you were to return it, let's say a week or two later, the value has already dropped since then. So yes, as the age of the car in years increases, the value of the car decreases in terms of its value here. Determine whether the graph shows a positive correlation, a negative correlation, or no correlation. Now, if there's a positive or negative correlation, describe the data. In other words, describe the relationship of that data. So, what is the correlation? So, if you said a positive correlation, you're correct. Now, if you were sort of bordering on the answer of no correlation because you look over at this particular, the left side of it and notice that it looks somewhat scattered. However, if you notice, they are still moving from left to right. In general, these data points are moving in an upward motion. So it does clearly show a positive relationship. It may not be a strong positive relationship. It may be weak to moderate, but it is a positive relationship. When you get into your statistics class, you'll get into more about the strengths of data. Some data that are more clustered together we would consider a strong correlation, and then data that maybe not so clustered together, such as these, we would say a weak or moderate correlation, but there's clearly a positive correlation here. So next, let's describe that data. So remember, we start with the x-axis. As the hours spent studying increases, the score on the final exam, what's happening to these dots moving from left to right? They're moving upward. So we would say as the hours spent studying increases, the score on the final exam increases. So that is an increase relationship. So what type of correlation does this data have? That's correct, no correlation. Notice here that this data from left to right, the dots are not clustered together and moving in an upward motion from left to right, and they're not moving downward from left to right. They're sort of scattered all over the place. So this tells me that they found no correlation between the number of books that a person borrowed versus the fines in dollars that they accumulated in library fines. So there was just no relationship between these two sets of data. Now, I always like to relate any skill that we're working on to a real-world problem. So here we're given the net annual sales of for Target in billions of dollars from 2009 till 2014, and it's given to us in a table of values. When you have a table of values, whatever is represented in that first column is normally your x coordinates, and whatever you have in your second column represents your y coordinates. So if we were to write these as an ordered pair or pair data in order to create a scatter diagram, it would look like so. So you would just simply take these points then, and then you would go and plot them. And once you plot them, you'll be able to analyze that data to determine what or if there are any trends or correlation between the two relationships. So here's the data. We went ahead and graphed the data for you to create what we call a scatter diagram, aka scatter plot. So what is the correlation of this graph? Okay, so you said there was a positive correlation. Now, was there a positive correlation throughout from 2009 to 2014? No. I see there was only a positive correlation from 2009 to 2012. So from 2009 to 2012, we can say that as the years increase, so did the net sales. But again, that was only during that period from 2009 till 2012. So what happened after 2012? Well, after 2012, you notice here that the data points remain the same. And in math, we use a term as constant. So from 2012 to 2014, it remained constant. Your sales remain constant, and that's how you would represent that data